Hello. In this video, we're going to talk about SSS and what it stands for. So, if you look at your papers, you see something called the SSS postulate. If you think you know what the SSS postulate stands for, please write it right here at the top. If you wrote side, 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 you're right. Because what this postulate means is it is another way to show that two triangles are congruent. Two triangles are congruent. What it means is that if you can show that all three sides of one triangle are equal to all three sides of another triangle, those two triangles are in fact completely congruent to each other. So, what does it look like? In this example, we've got two triangles. And if we want to prove by side, 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 the side, side, side postulate, that they are in fact congruent, we need to make congruent statements showing that each side is congruent to the other side of the other triangle. So I'm going to start by looking at the triangle over here. And I'm going to write segment AS. AS is like what segment on the second triangle? If you think you know what it is, go ahead and write it in over here. If you wrote UN, you're right. Those are identical sides on each triangle. Go ahead and attempt to write in what each of the other two sides from the triangle on this side, how they correspond to the triangle right here. So you might have something that looks like this so far. You're going to need to figure out on the triangle over here how UC compares to this triangle. If you wrote this, you'd be correct. What we're doing is we're comparing every side in one triangle to every side in the other. And if you can do that, it proves those two triangles are congruent. No longer do you have to state all of the angles too. In fact, if you can just say all the sides, you already know all of the angles are the same by the side, side, side postulate. Let's use this in practice. So, at the bottom, it says mark all something. I want you to do tick marks and mark vertical angles. So what you're going to do is you're going to mark all the sides that use the reflexive property. And you're going to mark all the sides that have, or all the angles that are vertical angles. Because if you can mark those, that's going to help you figure out what parts of each triangle are congruent. And the more things you can show are congruent, the more likely it is you're able to prove two triangles are congruent. Now in this example, we're actually going to try to prove on number one whether or not these two triangles are congruent by just side, side, side. So first, if you take a look at this, mark the side that's shared between the two triangles with tick marks. That will indicate the reflexive property. If you do that, you would end up with all three sides being congruent. So for example, on this bottom triangle, we've got a side with one tick mark, just like on the upper one has one side with one tick mark. On the bottom triangle, we have one side with two tick marks, just like on the upper side, upper triangle, we have a side with two tick marks. And then in the middle, they each share the center segment, which by the reflexive property means that they're congruent. So since they each have three sides equal, you would say yes, they do represent side, side, side. Go ahead and mark all of the reflexive sides and angles in both of these, vertical angles, in both of these, number 1 and number 3, and then tell me yes or no based on whether you think the side, side, side postulate is demonstrated. I'll give you a moment to do that. All right, here we go. So on number 2, I had to put tick marks on the center segment because it's shared by the reflexive property. It's congruent on both triangles. I also noticed that each of these triangles on the left and right have a corresponding side that's the same length for each triangle, and there's 3 of them. That means this is in fact congruent by side, 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 so I wrote the word yes. Now over here, it's a little bit different. They don't share a common side. They do, however, have vertical angles, so those are congruent. But if I wanted to show that this was congruent by side, 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 I'd be disappointed because not all 3 sides can we mark congruent. There's no property that says that we can say this unmarked side is congruent to the other unmarked side right there. So you can't put any tick marks there. There's no reason to do it. It's not the reflexive property. So you would say no. They do not demonstrate side, side, side.